This is a graph of y is equal to 3 minus 4x minus 2x squared. Find the algebraic equation of the graph after a stretch parallel to the y-axis with a scale factor of 3, and find the algebraic equation of the graph after a stretch parallel to the x-axis with a scale factor of 0.5 or half. Okay, so if we let f of x be equal to our function 3 minus 4x minus 2x squared, a stretch parallel to the y-axis, i.e. a vertical stretch, scale factor 3, is represented by f of 3 times f of x. So, if we want to work out 3 times f of x, we need to multiply every term here by 3. So it's 3 brackets 3 minus 4x minus 2x squared. Multiplying through, we're going to get 9 minus 12x minus 6x squared. Now, if we look at the graph of that, if this is the original function, the green one here, y is equal to f of x, which is 3 minus 4x minus 2x squared, and here the red one is the vertical stretch, or stretch parallel to the y-axis, and we get 9 minus 12x minus 6x squared. Now, if you notice here, the x-coordinate of the maximum point stayed the same, but the y-coordinates get increased by 3. So 3 times 5 becomes 15, and that happens to every coordinate from the original function to the image. Now, if we got f of x as 3 minus 4x minus 2x squared, and we want to do a stretch now parallel to the x-axis, i.e. a horizontal stretch, scale factor 1/2 is going to be represented by, now you need to find the number, you need to do 1 divided by 1/2, which is 2. So we will need to do y is equal to 2x. So that, y is equal to f of 2x. So that means everywhere there's an x in here, we will now have to replace it with 2x. So f of 2x is going to be equal to 3 minus 4 times 2x minus 2 times 2x all squared. So that's going to be equal to 3 minus 4 times 2, which is minus 8x. And then we'll just do this one stage at a time. So 2x all squared becomes 4x squared. So it'll be minus 2 brackets 4 squaring the 2, x squared squaring the x. And then the final line, we've got 3 minus 8x. So I'm going to have minus 2 times 4, which makes minus 8x squared. Now, if we look at the graph of this, so again, here we have the graph of y is equal to f of x, which is 3 minus 4x minus 2x squared. And the red one here is the stretch parallel to the x-axis scale factor 1/2. Now, you'll see that the y-coordinates stay the same at 5 for the maximum point, but the x-coordinate here is minus 1, and then on the image it will become half of that, which is minus 0.5. And the same for every other coordinate on the graph. This here, the same idea. Trying to find a convenient point. Here it will become halfway, and the same on this side as well. We can see here that this distance is twice this distance, or this distance is half of that distance, and that's what happens when we do a stretch parallel to the x-axis. Okay, I hope you've understood the video, and this has been a video to show you how to find the algebraic equation of a stretch parallel to the y-axis and a stretch parallel to the x-axis. I hope you've understood, and I thank you very much for watching.